Verify Green's theorem for integral over c xy plus y square into dx plus x square dy, where c is the boundary of the common area between y equal to x square and y equal to x. So we have to verify the Green's theorem for this integral, where the boundary of the region is parabola and straight line. Okay, now the given integral is integral over c xy plus y square into dx plus x square dy. Now the Green's theorem is integral over c u dx plus v dy is equal to double integral over r dou v by dou x minus dou u by dou y into dx dy. Okay, so this is Green's theorem. Now, by comparing the LHS with the given integral, u is equal to xy plus y square, because dx coefficient is u, here dx coefficient is xy plus y square. So by comparing these two, u is equal to xy plus y square and v is equal to dy coefficient x square. For the RHS, we want dou v by dou x and dou u by dou y. So dou u by dou y is equal to y differential is 1 into x plus y square differential 2y, and dou v by dou x is equal to 2x. From this, for the RHS, I want dou v by dou x minus dou u by dou y. So dou v by dou x minus dou u by dou y is equal to dou v by dou x is 2x minus dou u by dou y is x plus 2y. So now 2x minus x minus 2y, so that x minus 2y. So this is dou v by dou x minus dou u by dou y. So this is we can use for the RHS. Okay, so now I am going to find out LHS. Okay, for the LHS, I want to find out integral over c u dx plus v dy. For this, they are given one parabola and one straight line. The given parabola is y equal to x square and the straight line is y equal to x. Okay, now I am going to draw the diagram. So now this is y axis, this is x axis. Okay, now the parabola is y equal to x square. So this is y equal to x square is upward like this. So this is y equal to x square. And now the straight line y equal to x, it is passing through the origin like this. So this is y equal to x. Okay, so here the point of intersections are, this is one of the point of intersection, this is another point of intersection. Okay, now to find the point of intersection, we can solve this equation. So by solving means, so take y value is x square, substitute y value here, x square equal to x. When you take this x here, we will get x value 0 and x value 1. By substituting x value 0 here, y value 0. By substituting x value 1 here, y value 1. So the point of intersections are 0, 0 and 1, 1. So the 0, 0 is origin O 0, 0 and A 1, 1. So these are all point of intersection. Okay, now I am going to find out LHS of the Green's theorem. The LHS is line integral. So here the line integral, the closed region is, this is the closed region. So that I am going to find integral over C is along OA and along AO. Along OA is parabola, along AO is a straight line. Okay, so LHS of the Green's theorem integral over C u dx plus v dy is equal to, where C is along OA u dx plus v dy plus along AO u dx plus v dy. So this is the LHS of the Green's theorem. So first I am going to find out along OA. So here the O point is 0, 0 and A point is 1, 1. And now here the equation is along OA. From the diagram, along OA is, this is along OA, and along AO is this direction. So OA and AO. Along the OA is represent the parabola. So equation of OA is parabola y is equal to x square. From this I can differentiate dy is equal to 2x dx. Okay, now I am going to find out integral over OA. So integral over OA u dx plus v dy. So this is, they are given, it is xy plus y square into dx plus x square into dy along OA. Okay, now this is single integral. To evaluate this integral, I want to convert into single variable. But here there are two variables x and y. To evaluate this integral, I want to convert into one variable either in terms of x or in terms of y by using this. So I am going to put y is equal to x square here. Then the integral becomes in terms of single variable x. Okay, so now I am going to convert this integral x y value is x square. So x square into x is x cube plus y square is x power 4 into dx plus x square into dy. What is dy? It is 2x dx. Okay, now it is converted into single variable x, and now I want the limit for x. So here the limit for x is 0 to 1. So now we can simplify, we can find out the integral value. Okay, now I want to integrate this. So the simplification, integral over 0 to 1. Here x, we can take dx outside. So x cube plus x power 4 plus 2x cube into dx. Okay, so now integral over 0 to 1, x cube plus 2x cube is 3x cube plus x power 4 into dx. Now I can integrate. Integration of x cube, 3x cube integral is x power 4 by 4 plus x power 4 integral is x power 5 by 5, the limit 0 to 1. So substituting the limit, upper limit 3 by 4 plus 1 by 5, the lower limit 0 we can leave it. So 5 3s are 15 plus 4 by 20, so that it is 19 by 20. So this is along OA. So next I am going to find out along AO. So from the diagram, A limit is 1, 1 and O limit is 0, 0. And now the equation of AO. From the diagram, equation of AO is a straight line which is y equal to x. So that here equation of AO is y equal to x. From this dy is equal to dx. Okay, now I am going to calculate the integral over AO u dx plus v dy is equal to integral over the given integral xy plus y square into dx plus x square into dy AO. Okay, now this is single integral. I want to convert into in terms of single variable, either in terms of x or in terms of y by using this. Okay, now this is y equal to x. So I am going to substitute y is equal to x. Okay, so put y equal to x, x into x, x square plus y square. Y square is also x square into dx plus x square into dy. dy is dx. Okay, now you see this is converted into in terms of single variable x. The limit for x is 1 to 0. 1 to 0. Don't write 0 to 1 because along AO, from A to O, so that 1 to 0. Okay, now integral 1 to 0, x square plus x square plus x square, 3x square into dx. Okay, integration of this is 3x cube by 3. Limit 1 to 0. Cancel 3, substituting upper limit 0 minus lower limit 1, so that it is minus 1. So this is along AO. Okay, so after obtaining along AO, I am going to find out LHS. LHS is integral over C u dx plus v dy. It is along OA plus along AO. But first already we found along OA. Along OA is 19 by 20. And now we found along AO. Along AO is minus 1. So simplify this. Minus 20 plus 19. So minus 1 by 20. So this is the LHS of the Green's theorem. Okay, so LHS of the Green's theorem is minus 1 by 20. So next time I want to find out RHS of the Green's theorem. So what is RHS? RHS is double integral over R dou v by dou x minus dou u by dou y into dx dy. Okay, so double integral over dou v by dou x minus dou u by dou y. Already we found this from in the beginning of the problem. We found dou v by dou x minus dou u by dou y is x minus 2y. So I am going to substitute this value x minus 2y into dx dy. Okay, now next I want to find out the limit for x and y from the given diagram. Okay, so okay, now you see what the diagram. This is the diagram. In the diagram I am going to put either horizontal strip or vertical strip. Okay, so now I am going to put vertical strip. So here vertical strip like this. So if I put vertical strip, y limit is variable, x limit is constant. So x limit constant is limit 0 to 1. It is 0 to 1. But y limit is variable because it is vertical strip. So this strip starts from this parabola. From this parabola y is equal to x square. To this parabola is end with this straight line. From this straight line y is equal to x. So this is the limit I am going to use for the vertical strip. Suppose we can put horizontal strip also. Suppose if you put horizontal strip here, the limit is x limit is variable because horizontal strip means x limit variable, y limit obviously constant. So it is 0 to 1. For the x limit, the strip start from straight line. From the straight line, x value is y. 2. The strip end with the parabola. From the parabola, x is root y. Okay, so this is the limit for the horizontal strip. You can use any one of the limit for the integral. You will be getting same answer. But in this problem, I am going to take vertical strip this limit. Okay, so x limit is 0 to 1, y limit is x square to x. Okay, so I am going to use x limit is 0 to 1 and y limit is x square to x. X square to x. So variable limit is y, so y is the first integral. So this is from the multiple integral you studied in engineering mathematics 1 first semester. Okay, so x limit constant, y limit variable, so y limit only the first integral. So I am going to integrate with respect to y first. Okay. So now integral 0 to 1. Integration with respect to y. It is a constant. So constant integral is into y. Minus. Actually this is first integral with respect to y, means this can be changed into dy dx. Okay. So now the integration with respect to y is xy minus 2y integral is y square by 2. And limit x square to x, remaining integral with respect to x. Okay, now I am going to substitute limit for y. So substitute to cancel. Substitute limit for y, upper limit x into x, x square, minus substituting here x square, upper limit over, minus lower limit, substitute x square into x is x cube, minus substitute x square here, x square of square x power 4 into dx. But this and this cancelled. So here integral 0 to 1, take minus inside, minus x cube plus x power 4 into dx. So now this is I am going to integrate. So minus x power 4 by 4 plus x power 5 by 5, limit 0 to 1. Substituting the limit, upper limit minus 1 by 4 plus 1 by 5, lower limit 0, we can leave it. So take the LCM, minus 5 plus 4 by 20. So this is minus 1 by 20. So this is the RHS of the Green's theorem. LHS and RHS are same, therefore Green's theorem verified. Green's theorem verified.